All right, good evening. So hopefully this will be the first in a big series of videos helping you get through your pre-calculus homework. Okay, so let me go ahead and share my screen and we'll explain what we're going to do from there. Okay, so I'm sharing the screen. Okay, it's great. All right, so I'm looking at section 3.6, problem number 1. Just start where we're starting. So I'm going to go ahead and move this down a little bit. Okay, so this is 3.6, number 1. So you're supposed to have a scientific calculator. I don't have one that's with an app on it. I've got an app that uses it for my computer. You guys would probably use a regular calculator, especially for your exams. But that's what we have. I can't use a computer. Okay, or you guys can't use a computer rather. So you get to quizzes, you're kind of stuck with your phone. You're not stuck with your phone. You're stuck with an actual calculator. But most testing centers have a calculator that they will loan you. You only need a TI-30X2, and that's a TI-32. Mine's an S because it's solar, but if you have not the S, you have a batteries. Just realize you have to provide batteries if you ever run out of power, even on a cloudy day, so it should be just fine. These are generally about $10-ish to $20-ish rather. Okay, if you find one at a back to school sale. So these aren't too bad. Okay, and have all the buttons you would ever need to do anything. You're not supposed to use a graphing calculator because part of this is learning how to graph. Okay, so there we are. So I'm just going to start taking us through this and we'll see where we go. So what do we have here? We have populations of 2 countries for January 1st, 2000, January 1st, 2010, so 10 years apart. And they're saying, hey, by the way, we'd like you to use this model, okay? So the model that we're going to use is P equals P sub 0. Okay, let's go ahead and model for us, okay? Here. So we're going to say P equals, okay, so we have P equals P sub 0, E to the KT. E is a special number, okay? P sub 0, this is your initial population. And then K is what they're going to ask us to find, and T, usually time is in years, but depending on the application, time might be in days, it might be in seconds, but in this case, for population, for people, we want time, this is going to be in years. Okay, and how do I know that? It's because part of the way they dealt the problem to me was they were talking about years after. So since they gave me year 2000 and year 2010, I know that it is going to be in years, okay? And then they want us to just come up with this model. They just want us to fill in what are the values. They want us to fill in K. So let's go ahead and show you how to do that. Okay, so let's go ahead and have a look. That's this guy right here. Okay, so we're going to have 2 countries. We have Spain and Argentina. I think there's other countries depending on which one you're dealt with. Okay, so we have 36.9 in year 2000 and 40 million in year 2010. So we want P is equal to, what's the initial population? The initial population is the population we have in 2000. This is 36.9 million people. E, and then we have K, and then we're going to have a T here. What's the population in 2010? That's 40 equals 36.9 E to the K times. How much time had passed? 10 years had passed. Okay, and now we just have to solve this. We're going to solve this for K. Solve for K, right? So what are we going to do now? Well, because we're trying to solve for K, eventually we're going to need a logarithm. First thing I'm going to do is go ahead and divide both sides by 36.9, divided by 36.9. Okay, so what that's going to look like, we have 40 over 36.9 is equal to E to the 10K. Now, it doesn't matter. You can see K times 10 or 10 times K. It doesn't matter. We're solving for K. There's a variable in the exponent position. So what we're going to do with that is we're going to take the logarithm of both sides. Like, you're going to have to decide which base you want. Since we're dealing with something with an E in it, we want the natural log. So I want natural log, that's an L. So ln 40 over 36.9 is equal to the ln e to the 10k, right? One of the rules for the logarithms, right, is we are allowed to move the exponent down to the baseline. That's the whole point of taking the logarithm, right? So we have 10k times the natural log of e. That was equal to the natural log of 40 over 36.9, okay? So the only tricky thing I did here was logarithm. Make sure that you remember that logs are a side-by-side sort of operation, like taking the square root of both sides, or taking the logarithm of both sides. Natural log of e, okay, what this is asking us is saying, well, we have log base e of e. What is this equal to? So the way we do this, we say e raised to what power is equal to e? E raised to the first power would be e. So the natural log of e is just 1, okay? So we have 10k times 1 is equal to the natural log of 40 over 36.9. And then we go ahead and solve for k. K is going to be, right? K is going to be 1/10 times natural log of 40 over 36.9. Okay, and now I'm going to go to my calculator. I'm just going to write that in. Okay, so I'm going to say 1/10. That's the same as multiplying by 0.1, isn't it? So we can say this is 0.1 times. We're going to go over to our natural log key. Okay, and now in parentheses, okay, we have 40 divided by 36.9, 6.9, enter, and then we'll just go ahead and write that down. So our k is going to be this horrible. Okay, when we have our k's, I would recommend 4 significant digits. If they don't tell you otherwise, go with 4 significant digits. So this is 0.00. Okay, and then it looks like, what do we have here? We have 806679. So 4 significant digits. It's going to be 1, 2, 3, 4. So 8067. So 8067. That's just 4 significant digits. Okay. If they don't tell us, that's what we're going to go with, right? Sometimes they will tell us, sometimes they won't. But a good rule of thumb is 4 significant digits. That's fine. Okay. So we'll go in here and we'll say, okay, well, what do we want? We want P of T equals, what's my initial population? It's going to be 36.9. Okay, notice when you have an E, it's usually going to be E, and then we're going to use this caret button, okay? And then we have whatever we just wrote down, okay? So that's going to be our, sorry about that, 0.00. So we have 0, oh, there we go. 0.00. Oops, nope, I went 00. There we go, 00. Okay, and now we're just going to keep writing down our answer here. So that's 8, 0, 6, 6, 8. Okay, 5 decimal places. This is probably too much, okay, because I think they just wanted 5 decimal places. So 1, 2, 3, 4, 5. So we can probably say this is going to be 0.00807. I would recommend saying, think about this in significant digits rather than decimal places. And then we're going to do exactly the same thing for Argentina. Okay. We're going to have here for Argentina is we're going to say, same idea, right? P equals P sub 0, e to the kt. What do we start with? We want, for 10 years, okay, in 10 years, have 41.7, that's the current population, is equal to the initial population, 40.2, e to the k, I don't know what that is, times 10. We're going to solve for k. So we're going to say this is 41.7 divided by 40.2 is equal to e to the 10k. Take the natural log of both sides. So we have ln of 41.7 divided by 40.2. Okay, equals, and then we'll just have our natural log on the other side here. That's going to be the ln e to the 10k. This business here comes down in front. 10k times natural log of e. Natural log of e we just did in the last one. That is 1. that is equal to natural log of 41.7, and then we have 40.2 million people. And we're going to divide both sides by 10. So we have 1/10 is the same as 0.1 times natural log of 2.7 over 40.2. Okay, and that's going to be our K. So we're just going to go to our calculators now. We're going to write this down to significant figures. This is very susceptible to round off. Okay, so if you do this with somebody else and you round in different places, you have a chance of getting vastly different answers. Okay, that's one of the reasons why we have to be careful. So natural log of 42.7, so 42.7 divided by, okay, we have 40.2 here, 40.2, parentheses. We don't really need that, but there we go. So this was 0.006033. I'll say 2. So this is going to be 0.006 and then 0.332. And again, they only wanted 5 decimal places. I put in 4 significant figures, so it might be a bit different than what they said. Okay, so we're going to call it here. I'm going to say P of T equals. Well, we have our initial population, 40.2. So back here, 40.2. Okay, and then E raised 2. Okay, so they want this. I'm going to go ahead and use Shift 6 to give me a exponent there. Okay, and now we want 0.00. You don't really need the leading zeros, but I've taught enough of these classes to people who are nursing, so I'm just trying to model good behavior for that one. So this is 3, 3. Okay, 1, 2, 3. Put 2 in there. Okay, and then I forgot a big important thing here. This was times T. Okay, so we're going to put in times T. So that's our model. Okay, e to the KT. And we'll go ahead and check, fingers are crossed. Okay, and they're both wrong. Beautiful. Okay, what did I do wrong? 20, okay. I'm gonna go ahead and press go one more time, just to double check it to make sure. They'll tell me in a minute, but I want to see where I'm wrong. Okay. So I don't know why I know why they decided I was wrong, because this is not listed to the proper degree that they had specified. I will try to be more careful as far as doing that. Okay, but that's what they're complaining about, is that notice their right answer and my right answer. They are wrong. I am wrong because I carried this out to more accuracy. That's generally you want to stick with what they've done, but what they've said. But just doing this by hand as well, so it's usually something that say, of course, it's going to get bigger. So I'm more careful to play by their rules. Okay, use the model from Part A to determine down to the nearest 1,000. Oh, now we're going to go ahead. We're going to estimate the population in January 2020 for each country down to the nearest 1,000. Okay, so Spain had fewer people, and then we have more people. Why? Let's go ahead and show you how to do that calculation. Okay, I'm going to use the answers they gave me rather than go with my own stuff. Okay. So the current population, we have to say now time is going to be 20 years, right? From 2020 to 2000 to 2020 is 20 years. So we're just going to say, okay, well, for Argentina, okay, we're going to have 40.2 times second function ln. That gives us the E, doesn't it? Okay, so we have E, and I'm just going to go ahead and use their values there. Okay, they gave me the answer. So this was 0.00, okay, and then 366, yeah, times 20. Notice that it's still inside the parentheses. Then we'll just say enter. So I end up with how many decimal places do they want? So we're not going to get me again on that. Okay, nearest 100,000. So this is a million. So we want 43 million, and then the 100,000 is going to be the first decimal place. So it's 43.3. So it's 43.3 million. And then we're going to do the same thing for Argentina. Okay, so same idea here. So initial population, 40.2. Okay, so we're going to go 40.2. Okay. No, we're not. We want Argentina. I did it backwards, didn't I? I did do them backwards. I apologize. Let's go ahead and clear that out. Let's do it backwards. So 36.9, that's my initial population, times second function ln. Okay, and now we have 0.00 807 times 20, and parentheses, you don't really need that, equals, okay, 43.4. Okay, 43.4, it'll get mad. 43.4. Okay, so that 3 is going to change. Okay, now we'll go back to the Argentina one. I think I used a different number, so we're going to go ahead and say, what's my initial population? Did I do that right? Yeah, we're okay. Yeah, we're 2,000 with this one, with this column. So we're going to say 40.2. Okay, 40.2, clear 40.2. Okay, times second function ln. Okay, that's our e. And then we're going to say 0.00 and 366 times 20. Okay, and then we'll see what we get. 42 point, in this case, 42.3. So we have 43.3. 43.3. Okay, so that's our thing. So Spain would have slightly more people. Okay, so Spain has more people in Argentina because the growth rate, okay, is a little bit higher, right? So what's going on here? So this growth rate 0.008, 0.003 for Argentina. Okay, so Spain has a growth rate. Okay, and growth rate is higher. It's greater for Spain. Oh, Spain. Let's double check. Yeah, we're okay. That's bigger. It's a bigger number. Okay, double check. Okay, hooray, we got a green check mark. That's how we go. Okay, and then from this part, when would each one reach 60? So we can go ahead and say that. If this trend continues, okay, a lot of times that's how you know somebody's going to lie to you. It's like, if this trend continues, then the trends are almost never constant. But in this case, we're doing growth rate. That's how we work. But if you're taking a statistic with me, and it's like, if this trend continues, you have no evidence to think that's true. Okay, but generally we have over 20-year history here. That's not too bad. Okay, but a lot of times, if somebody's going to lie to you, this is their preamble. If this trend continues, what if that is not the trend that continues? Okay, then we're going to reach 60 million by the year. So let's go ahead and show you how to set that up, and we'll do that one. Okay. Oops, I don't want that. Go away. No, stop. Oh, jeez, stop. Let me pause. All right, I think that fixed it. Sure. So what we're going to do is we're just going to write down the equation here. So we have this trend continues. When is Spain going to reach 60 million? So we're just going to write down the value here. So we have P is equal to P sub 0, e to the KT. Okay, and they want to know what's going to happen in 60 years. Okay, well, when is the population going to reach 60 million? So we want 60 million. Okay, and this is for what? This is for Spain. Okay, Spain's population. So we're going to double check to make sure we have Spain written down here correctly. Okay, so this is going to be equals 36.9. Okay, and this is e to the 0.00807 t. Okay, and we're going to be solving for t here. We solve for t. So t. So what we're going to do is we have to solve for t. So we're going to divide both sides by 36.9. 36.9. Okay, so we have 60 over 36.9 is equal to e to the 0.00807 t. We're trying to solve for t. How do I get the t down to the baseline? We take the natural log of both sides. Technically, you can take any log, but since we have an e here, we're going to take the one where this turns into a 1. Okay, so we have ln of 60 over 36.9 is equal to this whole business here. This is the third rule of logarithms. This exponent comes down in front. So we have 0.00807t times the natural log of e. Natural log of e, that was 1, wasn't it? So what I'm asking is, we have log base e of e, that's e to what power, right? E raised to what power is e? Oh, 1. So that's why we get natural log of e is 1. Okay, and then we divide both sides by 0.00807. So we say 1 over 0.00807, okay, times the natural log of 60 over 36.9, and this is equal to t. Okay, so we're going to go to our calculator, we're going to type that in, we're going to get an answer. Okay, all right, so let's see here. We have natural log, I've got 60, 36, that's a 6 divided by, and that's a 36.5. So I got Spain's constant numbers here. Okay, and then we're going to divide this by, this is 0.00, this was what, 8, double check here for myself, I went 807, 807, right, and then enter. My time looks like it'll be about 61.6 years. So 61.6 years, that's when our population is going to hit 60 million for Spain, right? So we're going to go ahead and go back to this, okay? We'll say that's going to be in the year, when did we start with? We started with 2000. So this is going to be the year 2000, we'll say 62, okay? We'll round to the closest year. Okay, and then if this trend continues, when is Argentina going to hit 60 million? So we pretty much have to do that same dance, okay, now with Argentina's numbers instead of Spain's numbers. Okay, so let's see what we have here. Let's see, go back to Argentina, we'll go back to this guy right here. There's Argentina. Okay, so we're going to say, well, we're going to eat 60 million equals, and then what was my initial population? So this is our initial population, e to the, and we have Argentina's growth rate, don't mess that up, 0.00366. Okay, so this was 0.00366 t. Okay, how long did this take to happen? It took 20 years. Okay, so we started in 2000. They're asking us about, oh no, they're asking now, we're saying, when is this going to happen? So we went 60 million equals, how many people did we start with? Okay, we started with 40.2 million. Is our value in 2000. Okay, so we want 40.2 million. So we have 40.2 e to the 0.00366t. We're solving for t. Okay, solve for t. So what we're going to do is we're just going to divide both sides by our populations here. So we're going to divide by 40.2, divide by 40.2. Okay, so we have 60 over 40.2 is equal to e, that's a number, 0.00366t. We're just going to solve for t. So we need natural log of both sides. So natural log of 60 over 40.2, okay, is equal to the natural log of e to the 0.00366t. This business comes down in front because that's the rule of logarithms. That's the whole reason we're using a logarithm, so that exponent goes down on the baseline. Okay, so we have natural log of 60 over 40.2 is equal to 0.00366t times the natural log of e. We just learned in the last step that natural log of e is 1. Okay, so we're going to go ahead and divide both sides by the 0.00366. Okay, both sides. So 0.00366. Okay, so we're going to have T is equal to ln of 60 over 40.2, all divided by 0.00366. Okay, let's plug that in the calculator. We'll print that out. So let's go ahead and have a look. So we're say clear, and we'll say we want the 1 over, so 1 over 0.00366. We could also divide, that would work. Okay, times, okay, natural log. You know, we have in a natural log up. We have 60 over 40.2. So we have 40.2. Okay. So that should give us our population. That should be, okay, it's 109 years. Okay, so this is going to happen in 109 years. So this is going to be 2109.4. So the nearest year, I'm going to say it'll happen in 2109. Okay, so we'll do like a Buck Rogers time. So what, 2109. 2109. Can't imagine what the world is going to look like. Okay, so we'll check. It'll be wrong. Okay, what's wrong here? The number of digits is wrong. Check your answer carefully. Let's see. I'm gonna go ahead and say I'm just gonna recheck it because this one was right. I have a feeling that I rounded in the spot and it didn't like it. Okay, so what would Dave say? Oh, 2060 rather than the other one. So we'll just make sure we rounded, be more careful about where we're rounding, but that is how you do a problem like this. Okay, so I think you have a general idea of what we're doing, and I'll see you back in the next video. So thank you very much, and I will see you very soon.